Hello guys and welcome to today's video. Right guys, today's video I thought we would cover like differentiation actually. Okay, so differentiation in maths. So this is aimed at further maths, GCSE actually, AS maths and also A2 level maths. So we're looking at year 12 and year 13 and also obviously for like year 11s that have like extended their knowledge for GCSE maths. Okay, so today's video will be like a short video on that actually. Okay, so don't forget guys, obviously before I start my video, to press the subscribe button. Okay, so it's the big red button that says subscribe, and also obviously like my video. Okay, right guys. Okay, so differentiation guys, so the differentiation actually, okay, the rule is I've got y is equal to x to the power of n. So I've got a function y equals x to the power of n actually. So you've got f of x equals x to the power of n. Okay, so we've got some function of x actually, so y is equal to x to the n. So the rule is so the rule follows that dy by dx actually, so I'll come on to this actually in a second, is n times x to n minus 1. So dy by dx is equal to nx to the n minus 1. So differentiation is the rate of change of something actually. So it's looking at like curves, curves, quadratics, cubics, quintics, sine curves, cosine curves, tan curves. So graphs obviously as well as obviously like straight line graphs, and also like exponential graphs like that actually. Okay, so so we will come on to obviously in the like later videos actually about like how to actually like work out like this actually as part of like as part of like gradients gradients of like curves actually. So it's done guys, just actually summarize. Okay, so it's done to work out the gradient at a given point. Okay, so I will explain that hopefully in the next video, in the next couple of videos actually, just to be clear on what I actually mean by that. Okay, so differentiate y is equal to x squared. So y is equal to x to the power of n. So dy by dx is equal to n times x to the n minus 1. So the power comes down as a multiplier, okay? And then the power also comes down by 1. So dy by dx so it's 1 times 2 times x to the 2 minus 1. Okay, so 1 times 2 is 2. 2 minus 1, it will be 1. So it's 2x to the power of 1, which is just 2x. Okay, so that would be my answer. Okay, so differentiating y is equal to x squared actually gives us a gradient, not gradient, gives us dy by dx is equal to 2x. Okay, and what that means guys, just like summarize what that means is that for any value of x I can work out the gradient at that point. So for any value of x I can work out the gradient at that point, and that will become apparent when I start sketching graphs actually, and it will make sense like in the future videos. Okay, right, guys. Example 2. Okay, so we've got 4 more to go through, actually. Differentiate y is equal to x cubed, actually. So x cubed, so it's 1x cubed, okay? I'll put the 1 there just to obviously help you guys out, actually. Obviously, we don't actually need it there, actually, but I've just put it there just to actually help you out. So, dy by dx is equal to 1 times 3 times x to 3 minus 1. 1 times 3 is 3. 3 minus 2, 1 is 2. So my answer is 3x squared. Again, the gradient at any point here for the cubic graph, okay, can be calculated using this formula here actually, or like this part of my equation. Okay, so for any particular value of x, okay, I can work out the gradient at that point, okay, because the gradient will actually differ for each portion of the graph. Okay, and that's exactly why differentiation is done actually. Okay, right guys. Okay, example 3 guys. Y is equal to 2x to the power of 7. dy by dx is equal to 14x to the power of 6. So it's 2 times 7, which is 14. Okay, so I'll put it here guys. So dy by dx, okay, if you want the workings, it's 2 times 7 times x to the 7 minus 1, which gives us that as our answer. 2 times 7 is 14. 7 minus 1 is going to be 6. Okay, right, guys. Last two examples. Y is equal to x to the power of a half. Y is equal to 1x power of a half. Okay, so slightly more tricky, okay? So dy by dx here is 1 times a half, which is a half, times x to the half minus 1. So again, half minus 1 is minus a half. So it's again actually, so it's using our knowledge here of obviously rules with fractions. When we multiply a fraction by a whole number, okay, all we do is multiply the whole number by the numerator and keep the denominator the same, actually, if that makes sense. Okay, so I've done a video on like multiplying fractions that you can go and check out below. Right, a half minus 1, it will give me minus half, actually. So remember, a half, take away a half, is equal to 0. Obviously, 0 minus a half, it will give me, minus a half. Because minus 1 actually is made up by a half plus a half. Okay? Last example, guys. Y is equal to 1x to minus 1. So dy by dx, so it's 1 times minus 1, which is minus 1, times x to the minus 1, okay? So it's the power of it. So it's minus 1x to minus 2. So it's minus x to minus 2, which I can write it as minus 1 over x squared. Okay, because remember that the negative indices, x to minus 2 means 1 over x squared. Okay? Right, guys, thank you for watching my video, actually. I hope that was actually useful. Okay, please do obviously drop the video a like, subscribe if you're new, guys, and also, please enable notifications, actually, notifications, so it's that little bell icon to keep up to date, actually, with obviously videos that will be coming out. Okay, thank you for watching, guys. Tomorrow's video, actually, will be about, integration, okay? And then I'll be looking obviously more about differentiation, actually, and also about how to actually find actually differentiation for functions. Okay, so I hope that was actually clear, guys, and I hope it was helpful. Okay, thank you for watching, and I'll speak to you soon now. Happy Wednesday, guys. Bye now.